Hello everyone, today we're going to be talking about the alkaline earth metals. So we've got three learning objectives for today. First, we want to learn the properties of the alkaline earth metals. We're going to add a little bit to our periodic table by shading that column in and figuring out the charge of those ions. And we want to understand how parentheses can be used in chemical formulas around polyatomic anions. Before we get started, take a moment, make sure you have your periodic table, make sure you've got colored pencils, and make sure you've got a note paper and some pencils to take notes with. So the first thing I want you to do is pull out your periodic table and some colored pencils, and I want you to color in the alkaline earth metals. So the alkaline earth metals is the entirety of column 2A. That includes beryllium, magnesium, calcium, strontium, barium, and radium. And what I want you to do is color all those in and add them to your key. So you should have a key down here, and make sure you've added in alkaline earth metals under your metals category. Go ahead and pause this video now until you're ready to resume once you've finished coloring those in. All right, you ready? Let's move on. So these are our alkaline earth metals. Here you can see a picture of beryllium, magnesium, calcium, strontium, which here is being stored under oil because it will rust so quickly, and barium. So these are our alkaline earth metals and what they look like. Please note the name is alkaline with an I-N-E on the end, not alkali. It's very easy to mix these up with the alkali metals, which is column 1A. But these are a different group. So let's get started by practicing our atom drawing skills. So I want you to take a moment, and in your notes, I want you to draw 3 atoms. I want you to draw beryllium, magnesium, and calcium. As you're drawing these, I want you to pay attention to a few things. Think about how many electron shells they have. Remember, it depends on what row you're in. So beryllium in the second row should have 2, while calcium in the 4th row should have 4. And I want you to think about how many valence electrons, how many electrons in that outermost electron shell each of these is going to have. Once you've drawn these, I want you to take a moment and predict what you think the charge that these will make if they form an ion is. So go ahead and pause the video now, draw those 3 atoms in your notes, and once you've completed that, you can hit play again. Ready? All right, let's proceed. So let's start with beryllium. So if I look at beryllium, beryllium is in the second row of the periodic table. So here we drew 2 electron shells. It has 4 protons because its atomic number is 4, and it has 5 neutrons because its mass is 9.012, which is about 9, and 9 minus 4 gives me 5 neutrons. 5 neutrons. So knowing that I've got 4 protons to work with, that means I also have 4 electrons. So I'm going to start in the innermost ring. I fill in 2 electrons into the innermost ring. So now I've used 2 of my 4. I've got 2 left. I move out to the next ring, and I put 2 electrons in the outermost shell. So beryllium has 2 shells. The outermost shell has 2 valence electrons. Now let's look at magnesium. So magnesium is element number 12 on the periodic table. That means it has 12 protons. Magnesium has a mass of about 24. It's 24.305 on the periodic table. We round that. So 24 minus 12 gives me the number of neutrons, which is also 12. And because magnesium has the same number of protons as electrons, that means there will also be 12 electrons. So 12 protons, 12 neutrons, 12 electrons. The first 2 go into the innermost shell. So I've got 2 electrons in the innermost shell. Then I would fill in the second shell. Second shell can hold up to 8. I put 1 in each quadrant first, and then I fill in the second one in each quadrant. So I end up with 8 in the second shell, which are put into those neat little pairs. Then I've used 10 in total. So I'm left with 2 electrons left, because I have 12 total. So those 2 electrons go into the outermost electron shell, and they are unpaired. So you'll notice both beryllium and magnesium have 2 electrons in their outermost electron shell, so 2 valence electrons for magnesium as well. Now let's look at calcium. Calcium is element number 20. It is in the 4th row, so it has 4 electron shells, so I drew 4 circles around it. It has 20 protons because it's element number 20, that's its atomic number. It's got 20 neutrons because its mass is about 40, and 40 minus 20 is 20. And it has 20 electrons because it's the same as the number of protons. So when I'm placing those electrons, I can put 2 in the first shell, so then I've got 18 remaining. I can put 8 in the second shell, so then I've got 10 remaining. I can put 8 in the third shell, so I've got 2 remaining, and then those last 2 go in that outermost electron shell. So all of these elements, and in fact all of the alkaline earth metals, will have 2 valence electrons. Now, if we were to form ions, I would think, well, do these want to gain 6 electrons to fill that outermost electron shell, or do they want to lose 2? And the answer is they will lose 2 electrons. And if you lose 2 negatives, that's like subtracting a negative number, right? So when you lose something negative, it makes you more positive. So all of these will form ions with a charge of +2. So the key characteristic that makes the alkaline earth metals is the fact that they all have 2 valence electrons, which means they form cations with a charge of +2. So above column 2A on your periodic table, I would like you to fill in a little +2 just to help you remember that. Now we're going to take a moment and just take this name and think about what we can understand about the alkaline earth metals based on the name. So the first thing is they're metals. It's right there in the name. And like all metals, they've got the properties of metals. That means they are malleable. You can hammer them into different shapes without breaking them. They are ductile. You can draw them out into thin wires. They're conductive. They can easily transfer electrons or heat. And they always form cations. And for the alkaline earth metals, specifically, they will form cations with a charge of +2. The next thing to note about the alkaline earth metals is that they are alkaline. So you learned that the word alkali means basic. Alkaline means, they're basic too, just not as basic. So while the alkali metals, column 1A, made strong bases, the alkaline earth metals make weak bases. The difference between a strong base and a weak base is a technical thing about how many hydroxide ions you're going to add to your water for every molecule of base you add in. But what you mostly need to know here is that they're just not as effective at being bases as the strong bases are. Now, the alkaline earth metals have a charge of +2, but hydroxide anions, that negatively charged ion that makes something basic, they only have a charge of -1. So if you want to make a base out of the alkaline earth metals, you are going to have 2 hydroxide anions to balance out the 2 positive charges from the alkali metal. That means that the formulas for these weak bases are written like this. So here for beryllium hydroxide, you would have Be for beryllium, and then you'd put the hydroxide anion in parentheses, and I've put a little 2 subscript outside the parentheses. That 2 refers to everything inside the parentheses. So it's not saying that I have 2 hydrogens, it's saying I have 2 hydroxides, so 2 OH negatives. So in total, each hydroxide anion has a charge of -1. I have 2 hydroxide anions. That means I've got 2 negative charges from the hydroxides to balance out the 2 positive charges from the beryllium. So if I were to draw this out, I would have 1 beryllium atom, 2 oxygen atoms, and 2 hydrogen atoms in total in that molecule. So whenever you have parentheses as part of a chemical compound, know that everything inside the parentheses is affected by that number outside them. So the alkaline earth metals are another source of bases that we can reach. The other thing I want you to know about the alkaline earth metals is that they are found in the earth. Many gemstones are made out of salts of these metals. So I'm going to take a moment and show you what some of these might look like. So this is emerald. Emerald is a gemstone that you've probably heard of, And it is made from beryl, which is a mineral that beryllium is found in nature. So in nature, you would oftentimes find beryllium in these crystals like emerald. Here is an example of barite, which is also forms these beautiful crystals. And that's where you would find barium in nature, is in crystals like this. So the alkaline earth metals are called that because they are alkaline. They are they can form bases, weak bases, but they can still form bases. They are found in the Earth's crust, and they are metals. So if you are ever trying to understand the properties of the alkaline earth metals, just think about their name, because that tells you most of what you need to know about them.